Hey Ryan, let's go over this problem and explain it step by step. And all I did was print out your notes from the class, and you took notes well. That's a good thing. So on this problem, what you needed to do from the very beginning, once you had to apply the difference quotient to this function, where I had f of x plus h, all I do is I rewrite everywhere there's an x, I replace it with an x plus h. That's where this x plus h divided by x plus h plus 11 came from. And then minus f of x, well, f of x is this function, so that's why you see minus f of x. You're just substituting that in. And then, of course, all of that is over h. Now, the problem with this initial difference quotient is that you have fractions within a fraction. So the idea of how to get rid of those is you're always supposed to multiply by the least common denominator. So when you look at this fraction, you say, well, I would have to multiply by x plus h plus 11 to get rid of that denominator. So I did. Now, in this one, multiplying by x plus h plus 11 does not get rid of it. So I have to also multiply by x plus h plus 11. Now, anytime we multiply the numerator to get rid of those fractions in the numerator by these terms, we also have to multiply the denominator by those terms. So uh, after that step, you have to remember all of this is the least common denominator that you're multiplying by. All of that distributes to both terms in the numerator. This pen is not wanting to write on this paper, but it's going to distribute to both of those terms. When it distributes to the first term, you have, okay, well, the x plus h plus 11 cancels with this x plus h plus 11. So you're left with x plus h times x plus 11. That's where that came from right there. Then you say, okay, that's what happens when that term distributes to the first. What about the second term? I put the minus sign right here. And now I had an x over x plus 11. Well, that x plus 11 is going to cancel with the x plus 11 that I'm multiplying by in the least common denominator. But I'm still going to have x times the other factor that didn't cancel, the x plus h plus 11. Then after that, you do not want these multiplications in here unless they're factors. So from this step to the next, we FOILed out the first one, we distributed out the x in the second one. We got our x squared plus 11x plus xh plus h squared. And then minus the group of x multiplying this, where we have our x squared plus xh plus 11x, all of that being subtracted. And now, what I was wanting everyone to remember in this step is that the terms of f of x plus h, so all of this is still your f of x plus h. All of this is your f of x. The terms of f of x plus h and f of x always cancel. They never combine. So you could say, well, I know every term of f of x better cancel. X squared minus x squared cancels. XH minus XH cancels. 11x minus 11x cancels. So the only term you're left with, and another thing I'd like you to remember, the only terms remaining will always have a factor of h. Well, 11h clearly has a factor of h. There's an h in it. So then at that point, the final part of a difference quotient problem is you're going to have to cancel the h's out, or as I like to say, eliminate. So we cancel those h's out, and you're left with 11 still divided by those same two factors in the denominator. Now keep in mind, nothing ever canceled out those factors in the denominator. The only factor in the denominator that canceled was that h. But I think the main part of your confusion was why is this x plus 11 here and why is this x plus h plus 11 here? And it goes back to all of this is multiplying both of these terms here. When it multiplies the first term, that trinomial cancels out with this, leaving you x plus h times x plus 11. When this least common denominator multiplies the second term, the x plus 11s cancel, and you have the minus x times the remaining factor that didn't cancel, the x plus h plus 11. Okay, hopefully that made some more sense. Have a good weekend.